Today we will discuss about the charging and discharging of a capacitor. Till now we have discussed that capacitor is a device which store energy, but now we will discuss how it store energy, how the capacitor become a charge. So let, for example, this is a parallel plate capacitor, and when this capacitor is connected to any of the battery, see the process of charging. Process of charging means, if we are considering, let E is the EMF of this cell, the meaning is that this is at higher potential and this is your at lower potential, and these are the two plates of a capacitor. Two plates of a capacitor means these are the two separate conductors. So one of the conductor is connected to the higher potential terminal of a cell, another plate of the capacitor is connected to the lower potential terminal of a cell. As we know, when two conductors or two conducting objects which are at different potential are connected to each other, so charge flow from higher potential to lower potential. All electrons start flowing from lower potential to higher potential. In fact, during the process of flow of charge, electron normally participate in a conductors. See here. So earlier, before connecting to the cell, this plate does not have any charge as well as not any potential. So because of that, we can say this was at zero charge, this is also at zero charge. Now when this plate connected to this was at, for example, zero potential, this is your at negative potential or at lower potential. Because of that, electrons start moving from lower potential to higher potential. Similarly, this plate has zero potential because it does not have any charge initially, and this electrode at higher potential. So here electrons start moving from lower potential to higher. So when electrons start moving from lower potential to higher potential, so this plate becoming a positively charged, and those electrons through the cell now reaches to the another plate, then this plate here become negatively charged. In this manner, charge start flowing. So charge electrons start flowing from lower potential to higher, then lower potential to again higher potential. This process continue. As we know, the flow of charge will continue till both of the object or both of the conductors are not reaching at same potential. So finally, the potential of this electrode and this plate will be same, as well as potential of this electrode and this plate will also same. So the final potential between the plates is your same as the potential of the your cell. So we can say, if because of this potential, let charge Q came here, so Q is equal to your C into E, where C is the capacitance of a capacitor and E is the potential drop across capacitor. So this is the charge. So this is the called charging of a capacitor. In this manner, charge comes in a capacitor. Now, when charge comes, because of this charge, this plate your positively charged and this is your negatively charged. So that charge is producing electric field from positively charged plate to negatively charged plate, and because of this electric field there is certain energy, and that energy we can calculate by using our formula here, half Q square by C or half CV square, whichever formula we want we can use. So in this manner we can say capacitor have some charge and energy within the two plates. This is called your charging of a capacitor. So once capacitor charge means it store energy. Now when we have to discharge means when the capacitor is supplying energy. So let this is your charge capacitor. This is your charge capacitor, and charge on the positively charged plate is your Q while negatively charged plate is your minus q, and this value is same as in the previous case if we are considering the same situation. Now, if the terminal of a capacitor connected from a resistor, then what will happen? Resistor is nothing, it is just like your any electronics device. Let us suppose this is your bulb. The bulb is also nothing, electronic device or electrical device. Now, what I did here, this is your positively charged plate, this is your negatively charged plate. Positively charged plate we can have as higher potential and negatively charged plate is at lower potential. Now, with the help of this electrical device bulb, we are joining two plates which are at different potential with the help of a conducting wire. It means we are connecting two conductors which are at different potential with a wire. So, whenever potential difference between the two conductors is there, charge flow from positive charge flow from higher potential to lower potential. In fact, negative charge flow from lower potential to higher potential. So, earlier this plate was at lower potential and this is your higher potential. So, electron start flowing from lower potential to higher potential like this. This is the direction of motion of electron. So, as electron start flowing like this, so as per the convention, current start flowing from higher potential region to lower potential region. So, as the electron move from negatively charged plate to the positively charged plate, so amount of negative charge on this plate decreases and amount of positive charge decreases. This process again continue, and this process will stop when both of the plate having same potential, because flow of charge stop only when both of the plate having same potential. So, this process will continue till both of the plate are not reaching at same potential, and that situation comes when the charge on this here 0 and this also 0. So, whatever the negative charge in minus q charge when flow from this plate to this plate, so final situation is that both of the plate is completely discharged, and so whatever energy is stored in the plate or between the plates, that energy used in the form of your giving light if we are connecting a bulb, or it will dissipate as a form of heat. So, amount of energy dissipate in the form of heat again we can give by this relation. So, this is called your discharging of a capacitor. It means discharging of capacitor means we are taking energy from the capacitor. Charging of a capacitor means we are giving energy to the capacitor. So, now once capacitor your charge, we can transport this charge capacitor from one place to another place to get further energy. So, this is the process called your charging and discharging of a capacitor. So, one thing we have to remember, when the capacitor gets fully charged, so final charge on the capacitor will be your constant, and in that situation flow of charge will stop. So, when the flow of charge stop, it means there is no current from that branch across which capacitor is connected, and in the discharging process whatever the energy was stored in the capacitor, that energy finally discharged into the certain external device which we are connecting across the plates of two capacitor. Now, from the different example or different method we can solve certain problem. See the different examples.